Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we continue on the discussion of the operating system based on the structure part. So the previous video, we already learned about the implementation and design of operating system. So in this video, we look more on the structure of the operating system. And different type of operating system have different structure and architecture. The general purpose of the operating system is very large program, and it can be based on 4OS structure. We have the simple structure, the DOS part, so monolithic structure. This one is the simplest of the operating structure compared to the others. And then we have the second part that we call more complex, UNIX. And then layered and abstraction and microkernel match. So these are the four structures of the operating system. So let's look for the the original structure of the UNIX. So it limited by the hardware functionality. So the hardware also play a role for the operating system to work. The original Unix operating system had limited structuring. So it consists of two separable parts. The first one, it has the system program, and the second part, it has the kernel. Okay. Again, we heard about the kernel. So the kernel consists of everything below the system call interface. Okay, everything below the system call interface and above the physical hardware. And it provides the file system, CPU scheduling, the memory management, and the other operating system functions, a large number of functions for one level. So we have the physical hardware, and then above of the physical hardware, we have the kernel. And then we have the system call interface. Okay, these are the basic structure of the traditional Unix. So beyond simple but not fully layered. Okay, we have the kernel here. Okay, this one is what we discussed before. So this is kernel. We have the system call interface. So below the system call interface, we have the signal terminal handling, character of input output system, terminal driver, file system, swapping, disk, tape, CPU scheduling, and so on. So this one is below the system call interface, and the kernel interface is here. This one is referred to the hardware. So controller, device controller, memory controller. This one is the kernel. And then we have the shell, command, compiler, interpreter, system libraries, and then this user. So the user interact with this part, and this one will be linked with the system call. System call will goes to the services that provided by the operating system, and then it's linked to the hardware. So that is the traditional Unix structure. So next is about the Linux system structure, monolithic plus modular design. So it look like this one. We have the application, program application, the library. Okay, so this application with the library call the system call interface, interact with the system call interface. System call will this one provide the services. Still the same thing. The services are provided by the OS, the file system, the scheduler, the memory management, the input output, the communication. Okay, and then it has the device drivers and the hardware. So we had hardware, the kernel part, okay, and then system call, and then the application or the user part. So this is Linux. So you can look, it's quite similar, but not really similar. Not the same thing, but it's quite similar. Okay, so this Linux, this one is traditional UNIX system structure. So the next part, we go for the layered approach. Okay, we have 4, right? So the third part is layered approach. So the operating system is divided into a number of layers, level, and each built on top of lower layers. So the bottom layers, which refer to layer 0, is the hardware. And the highest layer, layer N, is the user interface. So basically, it's quite similar with the previous part because we still deal with the user, the program, the application, the services provided, the hardware. So the lower layer is the hardware, similar like this one. So if the question asks you about the similarity regarding the Linux, Unix, and the layered approach, you can say about that. The bottom layers is referred to the hardware. Okay, something like that. And then with modularity, layers are selected such that each use function refer to the operations and services of only lower level layer. So it's look like this one. We have layer 0, layer 1, layer 2, layer 3 until layer N, which refer to the user interface. Okay, the next part is microkernel. So it moves much from the kernel into user space, and much is an example of microkernel. Okay, we have 4 categories. We have the UNIX, Linux, layered approach, and Mac. Okay, so macOS X kernel, or usually we call as the Darwin operating system, it partly based on the Mac. So communication takes place between user module using the message passing. So we have another term, message passing, when they do communication between the modules. So benefit of the microkernel, easier to extend a microkernel. Okay, because the words micro itself, micro, it can extend. And then easier to port the operating system to new architectures. More reliable, less code is running in the kernel mode, and more secure. Okay, this one is referred to the operating system based on the Mac OS. Okay, determine performance overhead of user space to kernel space communication over of the user space. Okay, so now you already know about the Linux, the Unix, the layer approach, and the microkernel, or refer to the match or Darwin architecture, Darwin instruction. Okay, so in this microkernel, we have the application program here. So it divide into the microkernel part, easy to extend. Okay, it's still quite similar like the previous part in terms of the structure. The lower part, we have the hardware, and then this one is the kernel mode. So inside the kernel mode, we have the interprocess communication, memory management, CPU scheduling. So this one is under the microkernel, and we have the message that we talk here about the message passing for the communication. So between the module, okay, this one is the user module. We have the application program, we have the file system, we have the device driver. So this part under the user mode. So the communication is using the message passing. So this one will passing to here, and then this file system passing to the device driver, something like that. So the new part is the additional part here. We have the message passing module, and the user part we have. So at the user mode, user module. At the user mode, we have the application, the file system, and device driver. Okay, you can compare this structure with this one. This one is more simple to look on the diagram. Okay, actually it's quite similar. The different, it has the message passing. So this one is the user mode. Okay, at this one we also have the user mode, and then the kernel mode, and the hardware module. For the modules part, okay, user modules using the message passing. So we have the modules. So many modern operating system implement the loadable kernel modules, which is referred to the LKMs. Well, we have S here because we have multiple modules. So modules, LKMs. So use object-oriented approach. Okay, using on the modules, it use the object-oriented approach. I believe everyone already familiar with the object-oriented one. So means we have the object, and then what are the associated with this object. So this is the use object-oriented approach. So each talk to the other over known interfaces, and each is loadable as needed within the kernel. So overall similar to the layers, but with more flexible. For example, apply on the Linux and Solaris. We also have the hybrid system. So most modern operating systems are not a pure model. Mostly we already mix together with another model. So hybrid combine multiple approach to address performance, security, usabilities, and needs. Okay, usability needs means in order to achieve certain performance, we mix the model that we already have, means the pure model, and then we mix with certain structure. The objective is to get better performance, to have more secure operating system, as well as the usabilities. Okay, Linux and Solaris kernel in kernel addresses space, so monolithic at the first part. Okay, and plus modular for the dynamic loading of the functionality. Windows mostly monolithic plus the microkernel for different subsystem personalities. So most of the current operating system, actually it is a hybrid modern operating system or hybrid system. And Apple macOS X hybrid layered Aqua user interface plus the Cocoa programming environment. So Apple also implement the hybrid approach. So below is a kernel consisting of the mesh, microkernel, and BSD UNIX part. So plus the input-output kits and dynamically loadable modules called kernel extension. So basically what we have, the current or the modern one, is the hybrid system of operating system. Okay, we have the for the Mac and for the iOS, iPhones, Apple's products, okay, Apple architecture. So this is referred to the architecture of Apple's macOS and the iOS operating system. So we have the application, user experience, and the application framework, core framework, and kernel environment. So kernel environment for Apple product is referred to the Darwin. So the application interact with the user experience, and then application framework, core framework, and it also interact with the Darwin kernel environment. So basically, idea is for the Mac or for the iPhone, it's have this quite similar structure. Okay, so this one for the Darwin structure. So it's look like the previous one. We have the application and then the libraries interface for the system call. So libraries interface will interact with the system call. We have the POSIX and match trap. Okay, and then it will interact with the scheduling, IPC, memory management, and we have the match kernel here. So here we have the IO kit and KX. So these are the Darwin structure. Okay, now we know about the iPhone based on the Mac, quite similar. The next part is about the Android OS, that very familiar, very famous currently. So this Android can be used as the operating system for your TV, for your tablet, for your phones. Okay, and some projector also use the Android as the operating system. So these are developed by Open Handset Alliance, mostly by the Google, and it open source. Okay, similar stack to the iOS and based on the Linux kernel, but it modified the Linux kernel to another structure that provide the process, memory, device driver management, and adds the power management. So runtime environment includes the core set of the libraries and Dalvik visual machine. So if you want to develop a application or software that can run in the Android operating system, you can use the Android Studio in order to develop your program. So runtime environment include the core set of the libraries, Dalvik and visual machines. Apps developed in the Java Plus Android API. In Java class, a file compiled to the Java bytecode, then being translated to executable that runs in the Dalvik visual machines. So executable means that translated to the .exe file. So library includes the frameworks for the web browser, WebKits, and database SQLite, multimedia, and smaller library. So means it also allow you to have the multimedia interaction, install the data to the database. So this is for the Android. And then this is the Android architecture. So it's mentioned Linux with several modification. So this one is application, and then we have the visual machine, Android framework, JNR here, and then we have the library, smaller library that deal with the database, the OpenGL, the WebKit, the SSL, the Service Manager, and the media framework. And then we have the HAL here, UNIX, and Linux kernel. And the bottom part, we still have the hardware. So this one, we have the kernel. So basically, quite different at this point. Yeah, at this point, quite different when we try to compare to the iOS. Okay, this one iOS based on the Darwin. Okay, not Darwina, but Darwin. Okay, so that's all for the Android operating structure. So basically, we have four, and for the modern part, already mixed around, and we call it as the hybrid system. So that's all for chapter 2. So hopefully in chapter 2, you know more about the operating system structure and service provided by the OS. Basically, we just learn about the general part or generic knowledge regarding the operating system. We are not go for details on certain operating system. So that's all. Thank you and Assalamualaikum.